Welcome back to this lesson on storage fundamentals. Let's think about data. We have lots of data spread across different gadgets and devices. It could be rewritable CDs, could be those hard drives or SSDs. I don't think we have floppies anymore lying around, but basically, these are the most common types of media that we as individuals have and always use them to store our data. Now let's think about an organization. How much data do they have? How much data are they going to manage? You can imagine how unmanageable it would be to have all of these different mediums lying around where you store your data. So many organizations within your data centers use something called as a storage array. A storage array has many hard drives installed inside it, so organizations use the storage array to store the data for long term and short term purposes. Organizations would have different kinds of data, and depending on that kind of data, they would have a particular kind of storage, isn't it? I'm referring to object storage, file storage, and block storage. Let's take a step back and understand these as it is very important to know them. It is no secret that data is changing, and data has been growing explosively in the world. In every industry, data is stored with high fidelity than ever before. We have moved from traditional architecture to new means of categorizing, classifying, and storing the data. In late 1990s, object storage was developed. It is the general term that refers the way we manipulate and organize in units of data that we call as objects, as opposed to the most common data storage model, which is the block storage. Block storage stores data in fixed blocks, whereas file storage stores as a file hierarchy or a flat organization. Object storage stores in flexible size containers, which we call them as buckets or containers. Object storage consists of three things. One is the data itself. The object storage is dealing with storing unstructured data or data in the cloud. So it could be photographs, videos, or the product manual or documentation. The second piece is the metadata of the object, which includes additional information about the data, which can then be used for indexing and file management. The third piece is the globally unique identifier that is assigned to every object. So this is used to retrieve the data without knowing the actual address of the data. And this is what makes object storage much more faster. Object-based storage is perfect for massive growth of data that we have in today's world. Now, with this approach, you can scale up to petabytes of data and beyond. You can keep adding data indefinitely, and the sky is the limit. Now, I'm going to take you back to the previous scenario where we were working with the storage array to store that data. And this is how organizations or enterprises do it. From this storage array, we create volumes, and these volumes can then be used to separate and allow us to upload data based off different use cases. Let's say I want a different volume for every department, or I want a different volume based off the type of data that I'm going to store. So you're going to carve out some space from that bulk storage to upload the files. So it would be the same thing that you would do with an external hard drive at your home that you plugged into your computer and then saved your files into it. So when you think about how this storage space is being used and how we might carve it up, it is essentially a bulk storage. So you can think of a bulk storage as a giant hard drive where you can upload almost any type of data. That data gets accessed using some type of an application service with bulk storage. So there's no access to underlying operating system. So you might be using something like a Dropbox, Google Drive, or Amazon S3 as a cloud bulk storage service. You have no access to the underlying operating system that runs the service. But you do get a piece of storage that's carved out for you where you can upload your individual files. Once you create an account and you have access to those files, And you can then see those files, and no one else can see or access them unless you share that space out with them. Now we think about other types of storage. The cloud provider will be providing different kinds of storage. But keep in mind that operating systems will work great with block storages. When it comes to web applications, where the web applications needs to retrieve some kind of a file like a picture, photograph, video, document, it is great to have object storage connected with such services. Now let's map all of this discussion with AWS storage. Now, when we create an EC2 instance, you also create a volume for that OS, just like C drive and D drive. That volume is nothing but a carve out piece from some gigantic storage that Amazon has. We then install the operating system, and sometimes we add data to that as well. So when we think about this from a server perspective, things like web server, a database server, a mail server, well, these are all types of applications that you might potentially see installed on that server. So let's navigate to the AWS console here, go to EC2, and I've got the EC2 dashboard open, and I do not have any running instances, so I will launch an instance and click on this Amazon Linux 2 AMI and select that. And I'm going to leave this as T2 micro, leave this as default as well, and then pause near the storage section. So what do we have here? Now, what we are selecting essentially is the C drive. So root is a C drive for the Linux. So if you're choosing a Windows machine, it's going to be a C drive. And for the Linux machines, it will be a root volume. This size of 8 gigs that you see, this is being attached to your Linux instance. So this 8 gigs is residing on that remote storage array. And we're going to attach this volume to our EC2 instance. Now this is the space that we plan to allocate to our root volume. From a Windows perspective, this would be your C drive. This is where your operating system will be installed. And for Linux, it will be a different operating system. We can just look at it as a root drive, and this is going to be your 8 gigs in size. But you can notice that there are different volume types here. So this is going to be directly proportional to your performance of your EC2 instance. So in one of the lessons, we did discuss about these volume types. And we did mention that if you select magnetic, it's going to give you very less IOPS. And a good use case will be to create this magnetic volume type for sandbox environments or test environments, as opposed to provisioned IOPS, which will let you change the IOPS for that operating system. You can go up to 16,000 IOPS per volume for this block storage. So what you're essentially storing here is the data inside a block storage. Great for operating systems, but if you would like to have files, pictures, or videos, you know what to select. You will be selecting an object storage, which we'll be talking about in the upcoming lessons. So that's all for this storage essentials lesson. Thanks for watching, and I'll see you in the next lesson.